Welcome back to WAPSI. Here, let me look on to the 14th question. Solubility of silver chloride is least in. As you know, the solubility according to this question is the term we have to study is common ion effect. As you know, what is common ion effect? The solubility of a salt is suppressed by an addition of another salt having common ion. This is the main explanation of common ion effect. Here, the solubility of silver chloride is reduced due to the presence of these salts like sodium chloride, barium chloride and aluminum chloride. These all have common ion chloride. So, the question is which has the least solubility? All these three options have 0.1 molar, so everything is same. But the real reason lies in behind the amount of chlorine atoms. NaCl contains only one chlorine atom, BaCl2 contains 2 Cl minus ions and AlCl3 contains 3 Cl minus ions. Okay. The solubility of silver chloride is much less in pure water but higher than the remaining of. Here, the presence of 3 chlorine atoms suppresses the solubility of silver chloride. So, the correct option is fourth, 0.1 molar of aluminum chloride. Okay. Moving on to the next one. Which of the following equation does not represent the Charles law as given mass of a gas at a constant pressure? What do you know about Charles law? Charles law states that at a constant pressure, here volume is directly proportional to temperature. This is what Charles law. We could also write that V is equal to kT, where K is a constant. Okay. By given that K is equal to V by T. So, the option 1 is right. And giving by logarithm, log V is equal to log K plus log T. So, the option 2 is also correct. And by differentiating it with respect to temperature, dln by V by dt is equal to derivative of a constant is 0 plus dln T by dt, which is 1 by T. Okay. So, dln V by dt is equal to 1 by T. So, option 4 is also correct. The incorrect answer is log K is equal to log V plus T, which is absurd. So, the correct option is option 3. Okay. So, we will move on to the next question. Question number 16. Which of the most suitable reagent for the following conversion? Okay. Just look carefully at the question. Here, it is a methyl ketone to a carboxylic acid. As you know, what is the conversion of a methyl ketone to a carboxylic acid? Simple haloform reaction. Okay. This is a classic example of a answer lies in the question itself. Okay. So, here it is a haloform reaction. So, it is not a tolerance test. Tolerance test is a reagent used for the silver mirror test to determine whether it is a carboxylic it is whether to determine as a aldehyde or ketone. So, it is not a tolerance test, not a benzoyl peroxide, not tin and sodium hydroxide. The correct option is iodine and NaOH solution, which is iodoform reaction. As you know, the reaction is simple. R C double bond O, a methyl ketone when treated with X2, any halogen with an alkali like NaOH, which gives methyl ketone along with R C double bond OH. This is the haloform reaction. In this case, it is an iodoform reaction. The correct option for question number 16 is option number 2. Okay. We will move on to the next question. Which of the following is least soluble in water at 298 Kelvin? Temperature is irrelevant to this question. So, do not worry about that. Let us move on. How do you explain the solubility in water? It is actually about the hydrogen bond forming. Okay. So, here number of hydrogen present in the compound suppresses the hydrogen bond forming. Okay, here primary amine like is option 1 CH3NH2 contains 2 hydrogen which forms bonding with the lone pair of nitrogen. This secondary amine forms hydrogen bond with the lone pair which only contains 1. So it is a partial soluble. Both the primary and secondary are partially soluble in water. And the last one, tertiary amine, we could expel out the formation of aniline because aniline does not is least soluble in water, and the correct option would be tertiary amine because it does not have an additional hydrogen atom in the compound, which does remaining hydrogen atoms of the methyl group surrounding the nitrogen atom forms hydrogen bond with the water, which makes it more soluble. So the correct option for the question number 17 would be option number 2, which is tertiary amine. You guys are following up? Let's move on to the next question. Yes, same way, aniline. If an aniline is treated with 1:1 mixture of concentrated HNO3 and concentrated H2SO4, para-nitroaniline and meta-nitroaniline are formed nearly in equal amounts. Thus, there are given 4 options. The main our motive is to find out which is the correct one. Okay, so here if aniline is treated with 1:1 mixture of concentrated HNO3 and H2SO4, which is a nitrating mixture which forms NO2 groups on ortho and para position of aniline. So here aniline which gives what? Ortho and para position. Okay, the question is meta directing property of NH2 group. Okay, protonation of NH2 which causes the deactivation of benzene ring. Okay, and meta and para directing property of NH2 group. Both option 1 and 3 are wrong. This is because the protonation of NH2 group on aniline which gives that NH3 plus ion. Are you following up? NH3 plus ion, which is anilinium ion, which disrupts the benzene ring and thus causing a deactivation of benzene ring. Okay, this is due to the formation of anilinium ion, simply anilinium ion NH3 plus. So the correct option would be option number 2. Okay, let's move on to the next one. Yes, this is a simple biomolecules regarded question. In nucleic acid, the nucleotides are joined together by what? Phosphodiester linkage. Simple one. Option number 2. Question number 20. Which of the following is generally water insoluble? Same biomolecules, fibrous protein. Option number 1. Okay. Question number 21. Which of the following acids with their pK match the following acid with their pK value? Okay, this is one tricky question. This is because lower the pK value, higher the acid. Okay, we have to note the point that lower the pK value, higher is the acid, which means higher is the pH of the acids. Sorry, higher the strength of acids. Okay, lower the pH. Are you clear with the concept? Then we can move on to the question. Here there are given 4 options. Phenol, okay, phenol, para-nitrophenol, and ethanol. And picric acid. Okay, what do you mean by picric acid? It's a common name for 2,4,6-trinitrophenol. You have to be familiar with the concept of picric acid and other terms in order to complete this question. Okay, so it is very much important to know the common names of other compounds. So here picric acid is nothing but 2,4,6 trinitrophenol, okay, which is an result of excessive nitration of phenol. Okay, here, oh sorry, I have completed 2. Okay, these are the 4 options, and we are said to be which is much more acidic. We do know that the presence of a minus I group, which means like a negative inductive effect group, when present in a compound, it increases the acidity of the compound, right? So here nitro group, NO2 group is a minus I effect, which thus increases the acidity of phenol. Phenol is a ortho para directing group. Here picric acid has both ortho and para directing nitro groups. There are 3 nitro groups on both ortho and para. So the most acidic in this 4 groups might be picric acid, right? We do know that picric acid is the most acidic one. We will cancel out the remaining option which does not show the picric acid as the most acidic one. Here most acidic is picric, which means lower the pK value. That means option number 2, 0.78. Okay, we do know that D is 2. We could, yes, 1 is a correct one and 4 is a correct option. So we could rule out the option number 3 and 2. So what would be the next most acidic one? Phenol is less acidic than paranitrophenol. You do know that minus I effect of nitro group. So the next one would be paranitrophenol. So B would be the next one, which is 4, B4, which is 1, B here is 2. So option 4 is also wrong. Option A is the correct one. First one would be picric acid, which is 2,4,6 trinitrophenol. Second one would be paranitrophenol. Third one would be phenol, right? The presence of a benzene ring around the OH group increases the acidity of phenol. So the third one would be phenol, and the last one ethanol, least acidic one. So this is the series of acidity of 4 compounds according to this one. So here correct option is option number 1, right? Okay, we will move on to the next one. Which of the following can be used to test the acidic nature of ethanol? That's the question we have here. Ethanol blue litmus solution, which is used in rare conditions because ethanol does not show that much acidity. Sodium carbonate and sodium bicarbonate are not used for the test for acidity in ethanol. So we could rule out both the options and blue litmus solution. The correct option would be sodium metal. Okay, this happens a lot by forming a compound with the ethanol. Okay, we will be discussing the next one. Okay, we will be moving on to our next question. Which of the following possess net dipole moment? You know that the net dipole moment in a compound depends upon its molecular geometry. In these 4 options, we can write the BF3 is a trigonal planar structure like this one. Here, the dipole moment cancel out on the 3 sides of fluorine atoms. So, like fluorine attracts the bond and it attracts on the 3 sides. So, it cancel out the net dipole moment. Same way in beryllium chloride also the net dipole moment is 0 like this one. Carbon dioxide also has a net dipole moment of 0. This is because the structure of beryllium chloride and carbon dioxide, which is linear, and the different structure is that of sulfur dioxide or like bent structure. This is the structure of sulfur dioxide, which has two lone pair of electrons, which the net dipole moment is not is equal to 0. So the correct option for this question is option 1, is sulfur dioxide. We will be moving on to our next question. The number of pi bonds and sigma bonds present in naphthalene are respectively. You do know about naphthalene, right? Two fused benzene rings is called a naphthalene. See, this is the structure of naphthalene. Okay. Which have 5 pi bonds. So the total number of pi electrons present in naphthalene is 5. We could rule out the option 1 because it says 6 pi electrons. Now we will be calculating the number of sigma bonds present in naphthalene. There are hydrogen in every carbon present here. Okay. Therefore, there are 8 sigma bonds. Along with that, 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10, 11. 11 plus 8, which gives 19 sigma electrons. So the correct option for this question is 5 and 19, which is option number 2. Okay. Moving on to our next question. Which among the following is the strongest ligand? This question could explained by the spectrochemical series that we have studied earlier in a coordination chemistry chapter. You have to be familiar about this spectrochemical series. In this series, the most, which means the most strongest ligand is actually carbon monoxide. Okay. So so, carbon monoxide is the most strongest ligand present in this series. Along with that, we have Cn minus cyanide ion, and lesser than that is triphenyl phosphine or trialkyl phosphine, then nitrite, then we have En. So, for the answer to this question is carbon monoxide. Okay. The strongest ligand present in the spectrochemical series is carbon monoxide. Okay. Our next question is, oxidation state of copper is +1, which is malachite, cuprite, azurite or chalcopyrite. These are the options that were found in our question. So the correct option is cuprite. This is because Cu twice O. This is cuprite. Okay, which has an oxidation state of +1. So the correct option is option number 2, cuprite. Which of the following is an example of homogeneous catalysis? Okay, what do we mean by homogeneous and heterogeneous catalysis? In homogeneous catalysis, both the reactant and the catalyst are in the same phase, that is homogeneous, and in heterogeneous, both the reactant and the catalyst are in different phases. That is the simple difference between homogeneous and heterogeneous. Okay, we will be discussing about remaining reactions. Here the first one is an oxidation of ammonia in Ostwald process. As you know, Ostwald process is the manufacturing of nitric acid. So here ammonia is treated with oxygen 2O2 in presence of platinum, which is a solid catalyst. Okay, both ammonia and oxygen are in gaseous state. So this is an heterogeneous catalysis. Okay. The product for this equation are H2O plus HNO3. Okay, production of nitric acid. So option 1 is wrong. oxidation of SO2 in contact process. Okay, SO2 in contact process. Here, here sulfur dioxide. Sulfur dioxide is treated with oxygen. Okay, in vanadium pentoxide. Both these are gaseous. Okay, which gives sulfur trioxide, SO3. The next reaction, which is oxidation of SO2 in lead chamber. Okay, SO2 in lead chamber mainly is due to the fact that both sulfur and oxygen are treated in a chamber oxidized by in presence of NO2 catalyst. Okay, which gives SO3. Okay, here NO2, oxygen and sulfur are all in gaseous state. Okay, vanadium pentoxide is in a solid state. Okay, we have discussed the first three reactions. Here the third reaction, which is the oxidation of sulfur dioxide in lead chamber process, is the homogeneous catalysis. Anyway, we could also look after the manufacture of ammonia by Haber process. Okay, Haber process is simply but the manufacture of ammonia using nitrogen gas and hydrogen passing through iron. Here iron is the catalyst used here, and which gives NH3. Okay, this is also a heterogeneous catalysis. So the correct option is option number 3, which is oxidation of SO2 in lead chamber process. Okay. Moving on to our next question. The formula of penta aqua nitrochromium 3 nitrate. Okay. Here we must be familiar with the IUPAC naming of coordination ligands. Here we have given penta aqua nitro. We do know that penta means 5 water molecules. We could rule out the possibilities of option number 1 and 2. Okay, aqua nitrato, which means NO2 group. Okay, there are two types of nitrato group, N nitrato and O nitrato. This is the fact that NO2 is an ambident ligand which can both coordinate with nitrogen as well as oxygen. So, it's a penta aqua nitrato NO2 group, chromium 3 nitrate. Okay, NO3 is the nitrate, chromium 3 nitrate. Okay, so we must check the oxidation state of option number 4 to confirm the result. Here X plus 5 into 0, because water has 0 plus minus 1, which gives minus 2. Okay, plus 2, which is equal to X is equal to 3. Oxidation state of chromium is 3. So the correct answer would be option number 4. Okay. The correct formula for penta aqua nitrato chromium 3 nitrate is option number 4. There is a slight mistake in this question actually. We should not put spaces between the naming of any coordination ligands. I don't know why they have put a space between each word. Actually, there should be no space between penta or aqua chromium or 3 nitrate. It should be a joined word. Okay. Our next question is the plot of T half versus R0, which means initial concentration, okay, R naught initial concentration for a reaction is straight line parallel to the x-axis. The unit for the rate constant of this reaction, okay. We will move on to our graph here. Here T half against initial concentration, which is R0, okay, is a straight line parallel to the x-axis, which means initial concentration. The unit for the rate constant of this reaction is what they asked here. So, in order to determine the unit of this reaction, we have to find out what rate of this reaction. What is the rate of this reaction? Here, T half is independent of the initial concentration, right? It does not depend on the initial concentration. So, this is a first order reaction, okay. The unit of a first order reaction is always second inverse, okay. We could find the unit of a reaction by this general formula, mole liter inverse by 1 minus n, second inverse. We have to put n is equal to the rate of the reaction, okay. This is the general formula of finding the rate of the unit of a rate of a reaction. Here n is 1, 1 minus 1 is 0, mole liter inverse cancel out, and which gives only second inverse. So, this is a first order reaction. The unit of this reaction is actually second inverse, okay. I hope you understood this one. Our next question is, which of the following is not true regarding the usage of hydrogen as a fuel? Okay. This is completely hydrocarbon related method and petroleum chemistry. It has a high calorific value. It's true about that. It has a highly calorific value. The combustible energy of hydrogen can be directly converted to electrical energy in a fuel cell. That is also a true fact about hydrogen as a fuel. Combustion product is eco-friendly. As we all know that hydrogen is the most eco-friendly method in the present world. So, it is an eco-friendly combustion product. Okay, we are true about all these facts. We will move on to the last one, which is probably the correct option for this question. Hydrogen gas can be easily liquefied and stored. There is a problem here. Hydrogen cannot be stored and cannot be liquefied. So, here the fact that is not true about this hydrogen is option number 4, which is hydrogen can be easily liquefied and stored. That is false. This is fact that hydrogen cannot be stored and it is not easily liquefiable, okay. Our next question, the metal nitrate that liberates NO2 on heating, okay. Here we have 4 options: sodium nitrate, lithium nitrate, potassium nitrate, and it's actually lead nitrate, okay. We have a slight mistake in this. It's RbNO3. Sorry about that. It's actually PbNO3, okay. Lead nitrate is the question here, option here. So, we have studied that any metal nitrate on heating gives metal oxide along with NO2, okay. So, here the only metal nitrate present is lead nitrate. Other all are alkali metal. Even in sodium, lithium and potassium are all alkaline metal nitrates, which gives alkaline metal oxides along with along with carbon dioxide and nitrogen that does not produce NO2. For this, the correct option is lead nitrate, PbNO3 on reacting on heating, which gives PbNO3 on heating gives lead oxide and nitrogen dioxide. The correct option is option number 4, lead nitrate, PbNO3. We will be moving on to our next question. The elements in which electrons are progressively filled in 4f orbitals are called. As you know, f orbitals are mainly actinoids and lanthanides. Here, when electrons are filled to the 4f, it is called lanthanides, okay, lanthanoids. When it is moved on to the 5f orbital, we could say that it's an actinoid. So the question here is said that the element in which electrons are progressively filled onto the 4f orbital, which is lanthanides. So the correct option for this question is option number 3.